All right, so my name's Kito, and this session is called The Foundations of Modern Java Server Apps. And I'll tell you a little bit about myself. You can find me at these, does this pointer work? My pointer does not work, unfortunately. Huh, that's too bad. You can find me at Kito99. I'm actually not really on Twitter anymore. So you can find me on Mastodon or on LinkedIn or kitoman.com. I'm the principal consultant of Virtua, where we do architecture, mentoring, development, and training using a variety of technologies, including Java, Jakarta EE, web components, front-end development, mobile, web development, etc. I'm working on a side project called Speaker Tracks, which is a product for frequent speakers. You can check it out at speakertracks.com. The co-host of the Stack podcast, if you like podcasts. It's me, Daniel Inahosa, who's another speaker here, and another guy, Ian Levitz. We, every month or two or three, we do a podcast. And we talk about latest developments in front-end and back-end development. And then we also usually have a guest who's someone well-known in mostly Java community, but not always Java. We've got some AI people. We'll have different guests on. So if you like podcasts, you should check it out. I'm a member of the Java Champions and a member of the Jakarta EE Leadership Council. And I used to be involved in the Java community process, although all the specifications that I worked on are now part of Jakarta EE, so they've moved from JCP to the Eclipse Foundation. I used to be a Google developer expert in web technologies, and I speak at lots of conferences. So that's my story. I'd like to get a handle from you guys about your backgrounds. So how many of you are Spring developers? Okay. How many of you are Java EE or Jakarta EE developers? How many of you have worked with like some other microservice framework like Dropwizard or Micrometer or something else? Anyone? Okay. All right. How many of you don't write microservices? Okay. I'm going to see how many of you don't write. See, there you go. Okay, cool. So that helps. So what we're going to do today is talk about basically how people write quote-unquote modern Java apps and sort of what technologies are behind it and how they all work together. Okay. So I want to start with looking inside a typical Java microservice. Okay. And if you think about it, when you have a microservice, well, what is it? You have your code, right? But before you get to your code, you're usually in a container, right? You're in usually a Docker container or some sort of container, right? OCI container, et cetera. And then, of course, you have your executable jar or a native image, right? That's sort of your wrapper that you're running in. And then you have your code. If you think about it, like that's sort of the core, but there's a lot of stuff that you depend on to write your code, right? So, and what you depend on is usually some sort of microservice framework, right? And this provides all of the facilities that you need to actually do microservice stuff. And that stuff includes all sorts of things, right? It includes an HTTP server, right? Because most services communicate via HTTP. You don't have to, of course, you can communicate in different ways, but you need something to basically handle endpoints. So pretty much any microservice framework is going to have a web server, right? And you also need some way to integrate those web server requests with Java and then output them, the responses via Java. And usually, in many cases, it's the same code base, but these are two separate features, right? You also need some way to process a REST request, right? And return a REST response. So you need to process REST. And you also need to deal with JSON. And there's two different sides to dealing with JSON, right? There's serialization, and then there's also processing, or parsing, excuse me. So basically the idea that you take a JSON request and turn it into some Java object that you can work with, right? And so serialization, of course, is the opposite, where you take some Java object and turn it into JSON. Then you also usually need to do some sort of validation, right? Because you want to ensure that all the parameters coming into your request actually are valid. And just doing a whole bunch of if-then statements to check the strings and everything is kind of tedious, right? So a framework will hopefully give you some facilities to help you do some validation on the incoming requests. And you also need security, of course, very important. You need to be able to handle a JWT token or do other sorts of authentication, authorization, and role-based access control and that kind of fun stuff. And then, of course, you need to talk to some sort of database or some sort of data store, or maybe you need to do messaging. You need some way to sort of go beyond your application and interact with other data. And most Java frameworks also give you some sort of dependency injection, right? Because in the Java world, we like dependency injection. And it gives you the ability to sort of just get access to the services that you need without having to figure out where they are and how to instantiate them. And then, of course, messaging, as I mentioned, important. You need to talk to Kafka or JMS or some sort of other messaging service. You want to be able to do that. And then, there's also boring stuff like sending an email, right? There needs to be code to do that. You can, of course, write that manually yourself, but that's kind of a pain in the butt. So you need some API for doing mail. And then there's all of the sort of more modern microservice-y sort of things, right? There's health checks, there's tracing, because number one, you want to make sure that, there's a way for another application to be able to tell if your application is really working. That's a health check, right? And tracing is you want to be able to say, okay, how can I trace a request through multiple microservices? Then you want to have fault tolerance, right? So if you have a microservice that's talking to other ones, you want to be able to handle things like retries, timeouts, circuit breakers, things like that. Often this is done with libraries like failsafe or hysterics, or they're built into the microservice framework that you're using. There's also metrics, right? You want to be able to do counters and things like that to say, okay, this resource got hit this many times, et cetera, so you can do analysis on all the different aspects of your application, what's going on. And then there's also things you don't think about much, like configuration, right? You need a way to process a configuration file and then use that in your code, right? And then if you are building a REST interface, you want to be able to generate open API docs out of the box, right, without having to do anything special. And then, of course, if you aren't doing REST, you might want to use something else like GraphQL, or you might want to use something else like gRPC, right? So you might want another way to interact with the rest of the world beyond REST, okay? And of course, I'm not mentioning everything. Obviously, if you're doing a reactive programming, anyone done reactive programming before? With the Spring Reactor or anything like that? Okay. So, obviously, things can be a little more complicated when you throw in reactive, things like that. But this is basically the idea, right? You write your code and you get all of these cool services. Too bad my pointer doesn't work. You get all these cool services, right? And then you throw it inside of a jar file, and you throw it inside of a container, and then you put it in Kubernetes or some cloud service like ECS or Google Cloud Run or something, and you get it running, right? That's basically how we do things these days. So if you take a look at the most popular way to do microservices, Spring Boot, and people build Spring Boot apps, it'd be the same people who use Spring, right? All right, so if you look at Spring Boot in this context, you have this, right? So these are all the different things I just mentioned. But those are the actual features. Now, the question is, like, what is the actual API that you're using, right? For the web server part, you're basically looking at using Jetty, Tomcat, or Undertow, right? And if I remember correctly, Spring Boot, by default, you get Tomcat. And that is also what is used to integrate with the Java side of the world, right? So all of these servers, like Jetty, Tomcat, and Undertow, they implement what's called the Servlet API. And that is basically how you interact with an HTTP request, HTTP response, and all that kind of stuff. And for REST processing, for Spring Boot, you have some choices. Most people use the Spring MVC approach. But there's also the Jakarta RESTful web services, or Jakarta REST, which you can use with Spring if you want to, but most people do not. For JSON processing, again, you have choices with Spring. You can use JSON, Jackson, or JSON binding as well. For parsing, kind of the same thing, but there's also JSON parsing, JSON or Jackson. I know I ended up using Jackson a lot, but those are your choices. For validation in Spring, you use something called Jakarta Bean validation. And this lets you not only do validation on request parameters that come in, but also you can validate entire object graphs, right? So when you define an entity, you can say, okay, this string needs to be within this range, or this string needs to match a regular expression, or this value needs to be an email address, all that sort of kind of basic stuff, right? On the Spring side, on the security side, you have Spring Security, which is very robust, been around for a long time. For database integration, you have Jakarta Persistence, or JPA, and there are other options as well. For dependency injection, of course, you have the Spring framework, right, which is pretty much the granddaddy of dependency injection in Java. For messaging, you can use Jakarta messaging, which is called JMS, but also more commonly things like Kafka, things like that, right? For mail, you can use Spring Mail, Spring Java Mail Sender, or you can use Jakarta Mail. For health checks, you use the Spring Boot actuator, which is built in. For metrics, you use Spring Cloud Sleuth. Fault tolerance, you get Spring Cloud Circuit Breaker and Spring Cloud Netflix to help with that kind of stuff. Metrics, you get micrometer, which is pretty much become sort of the de facto standard for tracing. Spring Boot Config gives you configuration. Spring REST Docs gives you Open API. And for GraphQL, you have Spring for GraphQL, which is relatively new. So these are sort of all the different APIs that you get. And of course, this is not everything. There's things I'm leaving out. But this is a general idea of the different APIs that you use in a typical Spring Boot application. Okay. So we can take another look at a different framework. So we can look at Quarkus. Anyone use Quarkus before? So a couple of you. Oh, yesterday. Okay. Did you go to a workshop or something? Yeah. Ah, okay, cool. Did you like it?
It was a lot. It was fun.
That's cool. All right. So Quarkus is from Red Hat, and it does a lot of the same things, right? It has all these same features, but it does things a little bit differently. So for the web server part, it uses Eclipse Vertex, and for the HTTP integration, it uses Java Servlet. I believe you can also use some of the more traditional servlet engines as well with Quarkus. For REST, it uses Jakarta RESTful Web Services, so just the Jakarta REST essentially. For JSON, it uses Jackson or Jakarta JSON binding. For parsing, JSON parsing, it uses Jackson or Jakarta JSON binding, parsing, excuse me. For validation, it also uses Jakarta Bean validation. For security, it uses a combination of Quarkus security, which is its own sort of proprietary thing, sort of like Spring Security, but it also uses this thing called microprofile GWT as well. For the persistence, it uses Jakarta Persistence, and it also has something called Panache, which you can use, which is built on top of it's sort of like another layer on top of all the Jakarta JPA stuff to make things easier. You can also integrate with MongoDB and others as well. For dependency injection, it uses Jakarta CDI, which is very similar conceptually to the Spring framework, but it, lets you do dependency injection, and you can do interceptors and all sorts of fun stuff like that. So it's similar but different. For messaging, you can do Kafka, Jakarta messaging, others. For mail, it uses something called Quarkus Mail, which is sort of like the Spring Mail feature. For health checks, it uses microprofile health. For tracing, it uses OpenTelemetry. For fault tolerance, you get microprofile fault tolerance. And for metrics, you get micrometer again. For configuration, there is something called microprofile config, which it uses. And for OpenAPI documentation, you use something called microprofile OpenAPI. And for GraphQL support, there is something called microprofile GraphQL. So this is, again, a simplified version, but this is basically the idea. And again, I'm leaving out sort of the reactive stack, because Quarkus, just like Spring, has a sort of a separate reactive stack as well. But that's how things look in Quarkus. Another option, again, I'm only picking like 3 different microservice frameworks, but there's like, of course, many different ways to write microservices in Java. But another one is Payara Micro. Anyone heard of Payara before? Okay. So Payara is it's a fork of Glassfish, which was around a long time ago. You'll find they have a booth here too. And they have like a big main Payara, and then they have a micro version, which is more for microservices. So this is what it looks like. So it's a little bit different. So for the web server, it uses something called Grizzly, which has been around a long time. It was in Glassfish. It uses Java Servlet, again, for integrating with the HTTP requests and responses. For REST, it uses Jakarta RESTful Web Services. For JSON, it uses Jakarta JSON binding. For JSON parsing, it uses Jakarta JSON parsing. For validation, again, we have bean validation. You notice that bean validation is probably one of the most solid parts of this. You see everybody uses it. For security, you have Jakarta Security along with microprofile JWT. Database integration, Jakarta Persistence. Jakarta CDI is, again, for dependency injection. And how many people have heard of Hibernate before? Okay. How many people realize Hibernate is Jakarta Persistence? Okay, just curious, right? So Hibernate is an implementation of Jakarta Persistence. I mean, it is of course the most popular one. CDI again for dependency injection. Messaging, it uses Jakarta Messaging. It uses Jakarta Mail. Health checks, it uses microprofile health. And for tracing, it uses microprofile open tracing. And I think now this might be microprofile telemetry. I might have changed that one. Uses microprofile fault tolerance for things like bulkheads and retries and things like that. Uses microprofile metrics for metrics. Microprofile config. Microprofile OpenAPI for the documentation generation. And sadly, Payara does not have built-in GraphQL support. Of course, I'm sure you can do it with it, but it's not built in. Anyone here use GraphQL before? See, they should have accepted my GraphQL talk, and then I could talk about that instead. But anyways, GraphQL is really, I encourage you to check it out. It's a really good alternative to REST that actually has typed schemas, which make me happy. So I encourage you to check it out.
Things like, it shouldn't be called Payara, it should just be called Jakarta.
Well, you might think so, but there's actually a very good reason it's not. Now, I'll get to that in a minute. So, and I just backed up. Sorry about that. I wonder if I do show navigator, I should be able to jump to the next slide. All right. Okay, so you may have noticed that I sort of highlighted some of these things in orange and teal, right? There's a reason for that. And these are the APIs that repeated over and over. And if I were to go and pick another 3 or 4 different Java frameworks for doing microservices or any sort of applications that, are services, quote unquote, they would have some subset of these, okay? And the reason is that these are actually standards, okay? So these aren't things that just one company came up with. These are things that are developed through coordination of a few different companies so that they can be standardized across the Java ecosystem. And the first one of these is Jakarta EE. That includes all these orange items here. And the other one is a microprofile, which includes all of these teal ones, okay? So there's 2 sets of standards that are sort of underpinning a lot of the open source frameworks that we use for writing services. And obviously, they're not used for everything, right? Except for in the case of PR, perhaps. But they're used for some very key portions, right? So, and I'm changing that to microprofile telemetry because that's actually a newer spec. So telemetry actually will also cover microprofile metrics that has not been updated yet. But so we can take these specifications, right? And we can look at all the different specifications which are part of microprofile. And that includes the JWT stuff, all the fault tolerance, telemetry, metrics configuration, REST. There's also reactive messaging, which I didn't mention before, and reactive stream operators, long-running actions, and I did mention GraphQL. So these are all the different things which are specifications which are actually part of microprofile. And microprofile is supported by a variety of different products, which include Halidon, Apache Tommy, Fujitsu Launcher, OpenPyara, Quarkus, Open Liberty, excuse me, Quarkus, Pyara, Wildfly, etc. Okay, you can find these at microprofile.io. And if you're curious about where this microprofile thing came from, basically it started way back in 2016. So it's been around for a while. And basically what happened was, if anyone remembers, there used to be something called Java EE back in the day, which was the enterprise Java framework, which all these big vendors supported. But when Oracle bought Sun, after a while, Oracle just stopped developing Java EE, and all the other vendors were like, and users like myself were like, hey, we were using that, what's going on? Time is going by and you're not updating anything, right? So all those vendors got together and said, all right, well, let's create another group called Microprofile to work on open standards that work for microservices. Using a lighter weight process, since Oracle is sort of not doing anything with all the Jakarta EE stuff. Okay, so that's what happened, and that's where this organization came from. Let me just change my. Whoops, I did not mean to do that. That's what happens whenever you try to do something randomly. All right, I'll switch it back. Okay. And don't want to do that. Okay, thank you. All right, sorry about that. Let me go forward one more here. Okay, let me go back. Okay, all right. So that's microprofile, and that's where it came from. And that's the story behind it. So, every year there are new releases of all these different specifications, and these different vendors will come out with different products that support some subset of them, right? So if you're using Quarkus or Pyara or Open Liberty, those products, they implement all the microprofile stuff. So the other standard that I was talking about was Jakarta EE. So what happened was Oracle kind of dropped the ball with Jakarta EE, and microprofile got created, right? And then some of us created this group called the Jakarta EE ambassadors, or guardians, I think is what it was called back then. And our job was to sort of push Oracle to do something with all the Java EE stuff because they kind of were holding it in limbo. And eventually, Oracle said, all right, fine, we'll just donate all that code, all these specifications, we're going to donate it to the Eclipse Foundation. And that's what happened. So if you take a look at Jakarta EE today, like all those different specifications from all the old Java EE stuff still exist. Some of them are kind of dead. Many of them are still moving along. Some obviously much faster than others, right? And it's all open source as part of the Eclipse Foundation now. And it took like several years for all that to happen, of course, because it was probably like the biggest donation of IP, like, one of the biggest ones in history, essentially. So if you take a look at these specifications, though, there's something sort of key about a few of them, right? So if you take a look at something ubiquitous like JSON parsing, or JSON binding. Okay, this is very important, right? Any application that deals with requests and responses and data at this point is going to need to handle those things. You can also look at the ability to support like REST endpoints. That's kind of a key thing, right? And you can look at CDI, dependency injection, right? So if you take all those sort of things, and then you add a couple other things, you end up with what's called the core profile, okay? So in the bottom right-hand corner, there is the Jakarta EE core profile, which includes the RESTful web services, the JSON stuff, and CDI. In addition, it includes Jakarta interceptors, and well, we talked about CDI. There's CDI Lite is actually what's in the core profile. So just to clarify, CDI Lite has the ability to be used in native images. Most dependency injection frameworks do some sort of reflection fancy stuff, which is a problem for native images. So CDI Lite kind of factors that stuff out so that you can make native images with it. And then if you want all the other additional CDI stuff, you can use Jakarta dependency injection. And then there's also Jakarta annotations as well. So that's what we call the core profile. And that just came out, I think, year before last. And then on the left-hand side here is what we call the web profile. This includes sort of all of the APIs that you might use in a web application that might be bigger than a microservice, okay? So this includes the servlet API. It also includes that bean validation one that we talked about, which is very important, right? Also includes persistence and security, the expression language. So if you work with Spring, there's a little expression language you can use to do lazy evaluation of things, right? The Jakarta expression language actually came out first. That came out before the Spring one. So it's very similar. There's also other specifications. There's old things you might have heard about, like Java server pages or Jakarta faces, JSTL. So those are all part of the web profile. There's also a very new spec as part of the web profile called Jakarta data. And this is actually very similar to the Spring repository pattern. So whenever you use Spring, you have your repository goes, it gets data, things like that. And it actually, if I'm not mistaken, it was actually done in conjunction with the Spring folks, which I think is a really great sign, because it's a pretty standard pattern. You might as well make a standard way to do it that works on any framework, okay? So this is the whole Jakarta EE web profile. And this, to me, is pretty much the core of Jakarta EE. There is the core, the real core, which is the core profile. And then there's the web profile, which has most of the other stuff people use. But there's also the platform, which is actually much larger. So the platform includes all these other things, like there's actually a Jakarta batch API, which is similar to Spring Batch. There is Jakarta activation, which had to do with Java Beans. There's Jakarta messaging, which we talked about before, which mostly does JMS stuff. Oh, there's no reason it can't be adapted for more modern messaging APIs. Jakarta connectors, which connects to external data sources. Jakarta authorization, which is related to Jakarta security, which I probably should have put in here somewhere. Most of the list down there. And then, of course, good old EJB. Anyone remember Enterprise Java Beans? Nobody? Wow. Okay. All right. So all this stuff is part of the quote-unquote platform. And, not as many products support these features, but they do still exist. And then, of course, there's these old ones here, which are pretty much deprecated, right? No one's really writing much SOAP these days. And so that's what all this stuff is. This is mostly SOAP stuff. Huh? You still do? You still write new SOAP stuff, or you just have to support it? Okay. Are you talking to a government entity?
No.
Because I found like...
Unfortunately, no.
Okay, because the last time I had to deal with it, we were talking to a government entity, and that was why we had to do SOAP.
We still have legacy apps that are using SOAP.
Yeah.
So it's been fun.
Yeah, it's been fun. Actually, I had one client recently where we... they had some SOAP stuff in there, and actually it kept us from being able to upgrade to a newer version of, they were using WebSphere at the time. I wanted to switch to like Open Liberty or something, but we had to support all this SOAP stuff, which is not in the newer products, so yeah. Anyways, yeah, a lot of the technologies people don't like anymore. I don't really hate like a lot of people. Like I don't think XML is bad, for example, but I did not like SOAP. SOAP was a pain in the butt.
It's all right. It's all right. I have to tolerate it.
Yeah, it's manageable. At least it's deterministic. So, all right. So there's actually a couple other Java Jakarta EE specs as well. There's a couple new ones, and this is what's cool is there's actually new specifications coming out. And the way the specifications work is like there is an actual document that describes how it's supposed to work, and then there's usually one implementation that actually has that working out of the box, and then other companies or organizations can build other products that match the specification. Okay, and that's the beauty of it is that you can write to the spec, and then theoretically you can move from one application server or one platform to another. Okay, so there's Jakarta RPC, which is new, and that provides gRPC support. So if you're not using REST or GraphQL, you want to use gRPC as your communication mechanism, you can do that. And what's nice about it is that it is not tied to protobuf as a serialization mechanism. So if you want to serialize your request in some other way, you can do that. There's also Jakarta NoSQL, which, as you might guess, is for talking to NoSQL databases. So it's sort of like JPA for NoSQL databases. So that's there as well. There's also this specification called Jakarta MVC, which came out several years ago. But it is basically sort of like if you were to take Spring MVC or something to just build a web application using, without a lot of JavaScript, just a way to write a server-side web application. So that's out there. It's not too popular, but it exists. And you can use different templating engines like TimeLeaf or something else for that kind of stuff. And Jakarta management has been removed, which was for a standard management model for exposing and accessing different parameters of Jakarta EE applications. And I've never actually used that, but it existed apparently. So that's there. So what's been kind of interesting about this, like I was saying that, Oracle stopped working on it and all that kind of stuff. So it's happened, if you look at this sort of evolution here, we started with the old servlet, EJB, JMS stuff, and then all these different versions of Java EE came out. Some were good, some had issues, some did not. Well, I guess there are issues along the line for everything, but so more and more features got added. And I'd say, 6 and 7 is actually pretty good. And 8 was pretty good. But what happened was that between 8 and the Jakarta transition was several years. And that's where all the stagnation happened. But it's back. And so what you'll find is that if you use, I forgot which version of Spring Boot, but there's 6 where you have to do the Jakarta upgrade.
From 5 to 6, you have to use Jakarta.
Right. So, and that's because it uses all those APIs I mentioned, right? And they're actually doing a good job of keeping up with the newer ones. So 10 came out a couple years ago. 11 should be out later this year. And Spring is going to keep on updating along with those as well. So that's sort of what's happened over time. And now that the namespace transition is over, now I still have clients where we deal with that. We're dealing with that, getting them upgraded with all the Jakarta EE stuff, all the Spring stuff. But once you get past that hurdle, then you can add new features and everything. So, and I said before that basically there's different companies that implement these APIs, and there's actually a lot. So these are all different servers or products, I should say, not servers, that are actually compatible with Jakarta EE. Now, some of them aren't super popular. But there are a decent number of them. And a lot of them aren't, some of them are actually in China or Asia, other parts of the country. But there's a decent number of them. So these are all Jakarta EE compatible servers. And all of them do support those APIs. Maybe not every single API, but at least some subset of them. And these are all the different members of the Jakarta EE organization. And at the top, there are sort of the main members, the strategic ones, and then there's several other ones as well. So even though it's not nearly as popular as Spring. There is a lot of stuff going on. And it does underpin Spring and a lot of other frameworks as well. So now that we've sort of covered these things, I'd like to invite you to take a step back. So if we were talking about earlier a typical microservice, right, Java microservice, we said it looked kind of like this, right? And, excuse me, if you take away things like, the OCI container or Docker container, you can kind of see things a little bit differently. So I'll take you back a little bit further. And you could envision a Java EE server. So you guys sort of remember Java EE servers, right? And you think about it, they didn't look terribly different, right? They had all these same features, right? But instead of running as an executable jar inside of an OCI container, you ran as a WAR file, which is just a different type of zip file, essentially, running inside of a Java EE server, okay? So you could think of the WAR as sort of the boundary, right? And the Java EE server as something that can handle multiple containers, okay? So you think of it this way. These are all the different, again, Jakarta EE APIs. And what was interesting is back then, usually you had, in front of your app server, you had a web server. Like you had Apache, later you had Nginx or something. Now you'll find, most microservices, they just handle the HTTP requests using Jetty or Tomcat directly, right? But back then you would put Apache in front because Apache was really good at just handling web requests. And then you could also do other things like throw in static content and everything without having to worry about it, right? So this is what we had. And in reality, it was actually a little more powerful because we had the ability to have multiple WAR files, right? So you had an app server. The app server would have X number of applications running inside of it, and they would all share these services. Now, ran into some problems, right? Because you may have different apps that try to use different versions of things, and then you have conflicts, right? So, and on the whole, it worked out relatively well, okay? Now, if you take all these APIs that I'm talking about here, of course, you can expand it to have all the different APIs I talked about, right? So now we're talking about, sort of a big old application server that has all of these different APIs and lets you run all these different WAR files. And they also could support something called an EAR. Does anyone remember what an EAR is? So that was an interesting thing. So an EAR is just a different zip file that had, usually inside of it, could have multiple zip files inside of it. So it could have like a front-end WAR file and then a back-end jar file and things like that. So it's basically like a larger container for different types of code. That did go away eventually. Eventually it was like, well, why don't I just make it a WAR file? but that was an interesting thing at the time. So this is what we had. We have these big app servers. They would run on big hardware. They would run all these different little WAR files or EARs. And you could start and stop applications from the admin console, right? Similar to how you get sort of an admin console in Spring Boot or something, you would get one that just managed all of this stuff, right? So you could have different settings that you could set all configuration parameters for all these different APIs. You could do thread pools, things like that, fun things like that. Start and stop different applications, redeploy them without shutting down the whole server. So you could redeploy one WAR file and not affect the other ones, things like that. And you could actually control multiple Java EE servers, right? So you'd have multiple ones, you would have them together in a cluster. So you can even do things like share the session in between. So if you were doing load balancing and one failed, you'd have the session go to another server. So theoretically, the user would still be able to keep moving without having to log in again. And what was nice about this is, in some senses, it was a little bit easier because all apps run on the same platform, right? And it was relatively easy to manage. With some of these admin consoles, you could even control groups of servers. You could also, in some of the admin consoles, you could take a WAV file and deploy it to multiple servers if you wanted to. But the drawbacks were upgrades were pretty costly because each of these servers had all these different apps, right? They all might have different code, different requirements. You didn't have so much operational control. And the clustering was kind of a pain. You could do it, but it was kind of a pain, okay? So this is how things were. And what's interesting is that if you look at how we do things today, it's not terribly different, right? So today what happens is we have a whole bunch of containers, which are those OCI containers, right? They're running our jar file, which is just a microservice, right? Which just does one service, which is essentially like a WAR file, right? But the container is actually a Docker or OCI container, right? So, and because of that, each microservice doesn't have to be Java, right? It can be Python, it can be JavaScript, it can be whatever it needs to be, right? So in this scenario, it's quite similar to what the whole old Java EE days were like, but you have the flexibility to have any language you want, right? You could even have different operating systems inside the containers, right? And every app is not dependent on the same version of the platform, right? So with Java EE, it was like, okay, the app server was Java EE 6 or 7, and everything had to work with those versions of those APIs, right? Now, each of these can be completely independent. The orchestration layer is separate, right? But the concepts are similar, okay? And you can still do things like, push out something to several different pods and things like that, right? So from my perspective, it's always intriguing to see how things sort of change but stay the same over time. Okay. So that was my quick little blast to the past. So I want to wrap up with a few things here. So just going back to microprofile. If you want to learn more about it, you can go to microprofile.io, and also I think there's at the booth, I think you might be able to find more out front. So all these specifications are supported. Microprofile 7.0 came out recently, last year, and it has basically microprofile telemetry, which is based on open telemetry, handles both metrics and tracing. So that's pretty cool. The REST client has been updated as well. Open API has been updated. Fault tolerance has been updated. So there's been all sorts of minor updates recently. But if you haven't, I encourage you to check out some of these products like Quarkus or Howdon is really good. Most people don't know about it, but it's an Oracle product that's just an open source microservice framework. It's really good. There's other ones as well. Open Liberty, et cetera, et cetera. And again, if you want to learn more, there is the starter site for microprofile.io. It's sort of like the Spring Boot starter, but it doesn't have like 4,000 things. It has like maybe 15. So similar. There's the main site, and you can join the discussion and all that kind of fun stuff. And what's also great about all of these standards is that it's actually pretty easy to get involved. Whereas if you wanted to go to commit to a Spring project, it may not be the easiest thing to do. But for these, they're always looking for contributors. So you can pretty easily get involved and start, doing PRs and, just helping out if you want. On the Jakarta EE side, again, this is that same picture, right? And let's say, later this year, Jakarta E11 will be out. And that has some additional features, which I seem to have missed my notes on. Where are my notes? Huh. Oh, that's really annoying. Okay. Anyways, so if you want to learn more about Jakarta 11, there's a couple great blogs there. But Jakarta 11 has some nice little updates to several different specifications. And also what we're doing is sort of keeping up to date with more recent versions of Java. So if I remember correctly, I think this requires at least Java 17 and maybe like even 21, I'm not sure. So that's the story. And you can go to the Jakarta EE community and get involved link if you want to learn more about it. So that was sort of the main emphasis of this talk, is really just to understand what the foundations all of our code is built upon are. So you may be working with Spring Boot or some other framework, and a lot of people don't really realize all the different APIs they're working with. And this idea became clear to me when several years ago I was working on a project where we were, that particular organization, we were using Drop Wizard. Anyone heard of Drop Wizard before? So that was our microservices framework. And I realized some of the developers on the team had no idea that they were using like the Servlet API or Jakarta REST or anything else. They had no idea what APIs they were using. So that sort of helped me come up with this talk, because I think it's important when you're working with something to sort of understand what's underneath it and how it evolves. Because, things change over time, and having some idea that, I'm using this set of APIs underneath what I'm building, I think is important to know. So keep that in mind as you build your buildings, and I think you'll have a more fruitful time. So, all right. So that's pretty much all I had. I don't even have a goodbye slide. You can see what I was listening to, in case you're wondering there. I'll go back to this. I need to add a goodbye slide. All right. Anyone have any questions? No questions. All right. Well, thank you so much for your time, and enjoy the rest of the conference. This is hands down one of my favorite conferences. So thanks for coming.
Thank you.
Thank you.